All right, the last section that I want to go over with you is on half-life calculations. Now, there's actually two methods to half-life calculations. One is called the formula method, and one's the chart method. And in the previous video lesson, I talked about the methods, and um, sometimes it just depends on what they're asking you for. Sometimes it's easier to use the formula method, and sometimes it's easier to use the chart method. But I'm going to talk you through these two notes examples using both methods so that you can see them worked out the same. Problem worked out in two different ways. Now, for the formula method, the formula that we use is 1 divided by 2 raised to the n power. Notice the n is in the denominator. And that's times x initial equals x final. Now, n is representing the number of half-life cycles, the cycles that's gone through. X sub 0 is your original amount of your substance or your sample, and x sub f is the final amount of the substance. Now, another formula that is needed or necessary in both calculation methods that I'm showing you is the formula that relates your cycles in to your half-life, which, remember, half-life is the amount of time it takes for 1/2 of a radioactive isotope to decay. And then how it relates also to the total amount of time that has passed by. So, like, remember with half-life, like, for example, if you start with a 100-gram sample, after one half-life, you cut it in half. 100 divided by 2 is 50. You'd have 50 grams left. And then, so this right here would be one cycle here that this is referring to. And then from here to here would be another half-life cycle. And notice 50 divided by 2 is 25. And then from here to here would be a third cycle. And so 25 divided by 2 is 12.5 if you read that back to the graph. And then 12.5 divided by 2 will give you 6.25. That will be another cycle. So cycle, this is a cycle, this is a cycle, this is a cycle. So basically a cycle is representing how many times it's actually cut itself in half. Now, if you're going to use the chart method, the headings you're going to use are amount and cycles. And what you have to remember here is that for the cycles, you always start with 0 because this will be representing a time when no time has passed by, a time equal to 0. And then you would always match that up with your original amount that you started with. And then basically you just kind of cut it in half until you get to the point that the problem's referring to. So let's take a look at the first example, and I'm going to do these using the formula method first. So it says the half-life of iodine-131 is 8 days. So that means every 8 days it cuts itself in half and goes through one cycle. What mass of iodine-131 remains after 48 days? So this is our total time that has passed. If the original was 4 grams, so the original amount, that would be x sub 0 is 4 grams. And it wants to know what mass remains, so that means we're looking for x sub f. Okay, just kind of give everything in perspective. So let's write down our formula. The formula method will be 1 over 2 to the n power times x initial equals x final. And again, I encourage all of you to always write down your formula so you can plug into it exactly as it's written and not make a careless mistake. Now, they did tell us the half-life of the sample, and they told us the total time passed. And so since we know both those things, we can solve for n. So let's go ahead and find n. I'm going to do that over here to the side. N is equal to the total time. I'll put TT for total time divided by your half-life, T1 half. So the total time that has passed is 48 days. And the half-life is every 8 days. That means every 8 days it chops itself in half. So basically 48 divided by 8 means that 6 cycles have occurred. So n is 6. So let's plug into the formula. 1 over 2 to the 6th power times x initial, and x initial was given as 4 grams, equals x final, and we're looking for the final amount. So you've got to substitute into your, or plug it into your calculator. 1 over 2 to the 6th, if you say 2 to the 6th, that's 64. So that means 1 over 64 times 4 equals x sub final. So 4 divided by 64 is going to give you your final amount. X sub f is going to be equal to 0.0625 grams. Now, on these particular kinds of problems, since we're going to typically be dealing with very, very tiny answers, I'm not going to worry so much about sig figs. So just give me your answer, whatever your calculator tells you. So mine tells me 0.0625 grams. All right, so that's using the formula method. Let's look at the chart method. For the chart method, you are going to start with the amount as one column, and then the cycles. I'll put in for cycles here. Remember, the first cycle is always 0, and you were told your initial amount for this problem was 4 grams. Now, you still have to figure out your N. You have to use this formula on this method. So we already figured out in the beginning that it gone through 6 cycles. So this can get a little not cumbersome really, but it just takes up a lot of space. That's why I prefer the formula. But you basically have to chop it in half 6 times. I'm going to come on down here into this problem. 4, 5, 6. So when you get down here to the very, very end, whatever you get in this spot is going to be your answer. So let's just think it through. You kind of just think this through. So 4 divided by 2 is 2. 2 divided by 2 is 1 gram. 1 divided by 2 is 0.5 grams. 0.5 divided by 2 is 0.25 grams. 0.25 divided by 2 is 0.125 grams. And then 0.125 divided by 2 is 0.0625 grams. Notice we get the same answer both ways. A lot of students prefer the chart method. If you can figure out your cycles, all you got to do is just plug it in. You'd say 4 divided by 2 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 divided by 2. You just basically divide it by 2 6 times, and then that gives you your 0.0625. Alrighty, let's look at example 2. For example 2, it says the half-life of thorium-234 is 18.72 days. That's giving you the half-life. How many days? So they're actually asking you for the total time here. How many days are needed for 3/4 of a given sample to decay? Now, this one can be a little tricky if you're not careful, because what you got to understand, think in terms of a pie chart. What you got to understand is if 3/4 of it has decayed, okay, that means you kind of have to define your X initial as a whole. I'm going to just say 1 gram, make it an easy number. So that's what your X initial. So X final is going to be what? Think about it. If 3/4 has decayed, so there's 1/4 decayed, 2/4 decayed, 3/4 decayed. So how much is remaining? This little sliver here. All that remains is 1/4. So the X final is 1/4 of the initial, because 3/4 has decayed. So this is important to understand here. All right, so 1 over 2 to the n times X initial equals X final. This is our formula. You got to find n first. Okay, so we're going to substitute in here. X initial is 1 gram. X final is 0.25 grams. So what you're going to have to do is isolate your variables. So I'm going to say 0.25 divided by 1 is going to move this over. That's going to give me 1 over 2 to the n equals 0.25. And now you're going to have to do a little cross multiplication here and solving. So if you bring the 2 to the n up and then bring the 0.25 down, that's going to give you ultimately 1 over 0.25, which is 4, equals 2 to the n. And so that means that n, if you look at like 2 raised to what power equals 4, n must have to equal to 2 here, 2 cycles. So going back to our formula, we're looking for the total time that has passed. So n is equal to the total time divided by the half-life. So this is at